Hello everyone. My name is Jairaj and welcome to Spring Boot tutorial series by JR Academy. Thanks for joining again. This is tutorial 4, Understanding Maven and POM.xml, and this is going to be a little bit off topic tutorial because it falls in DevOps category, but I believe it is very important to know build process because in industry we need to do various different tasks along with coding, and this tutorial will help you to understand few things. And in this tutorial, we will look into these topics such as what is Maven and why we need Maven, how to install Maven and create projects with it, and then what is POM file and M2 folder, and what are some of life cycles and goals of the Maven. So let's get started. So what is Maven? First of all, history as always, because I like history and it makes everything interesting. So in 1999, Apache started Jakarta Turbine project to manage open source project on Java platform. And there were so many different projects, sub-projects in it, and Maven was one of them. And it began as an attempt to simplify the build process. And normally there are build tools for that. So now new question is, what is this build tool? And it is tool that takes care of everything about building process, and there are some tasks such as generating source code. So it won't generate like a whole source code, but a few parts of that such as boilerplate code and something like that. And the second is it helps you to compile code. It will generate class files out of your source code file, and then after generating class files we need to package it. So build tool helps to package compile code into jar or war file. So what is jar and war is a topic of another tutorial, and I will create video and put a link in the description. And after generating jar we need to deploy that jar in some repositories, and the build tool helps us with that. And after this whole process we need some documentation for our source code, and documentation is very necessary for developers to reuse the code. So this whole task is done by build tool. So Maven can do all of this, but there is more to it. So because Maven is a project management tool, not just a build tool. So it can do some of the major things at project level, such as maintaining dependencies. So what is dependencies? It is basically a jar file, and we need to download and deploy in our project. And the second is a release management. So if you have a distributed system and you have a back-to-back release, then you need to manage those release in different life cycle, and Maven can help you with that. Another one is a plugin development. So sometimes we develop some plugins for our project, and plugin is a kind of a feature you can plug with your project if you want the feature. If you don't want it, you can just remove the plugin, and Maven can help you to create plugins. And Maven also provides a lifecycle. So these are the features of Maven, and there are a bit advanced topic, but this is useful to know. So when Maven project was started at that time, the primary goal for this project was to allow developers to comprehend the complete state of development in shortest period of time. And for that, they have several areas, and Maven needed to deal with those areas. So those areas were making build process easy. So Maven provides a lot of shielding to the details of the of build project. So you don't need to learn so many things about build process. You just fire a few commands and you are good to go. Is that simple. And another one was providing uniform build system. So Maven allows a project to build using its project object model and a set of plugins. So that are shared by all the project using Maven. And once you familiarize with yourself with all these objects of Maven, and after that you pick up any Maven project, it is the same universally. So that uniformity is helpful when you are dealing with so many different projects. And another thing was provide project information and guidelines for best practice. And Maven provides plenty of useful project information, such as change log document created directly from the source code. So who changed what, you can create a document out of your source control direct. You can create a cross-reference sources. You can get a list of mailing list managed by the project. You can get the dependency list. You can do unit testing and generate coverage reports of it, and providing guidelines for best practices. So Maven uses a convention over configuration approach, which means developers are not required to create build process themselves. No need to mention each and every minute detail of it. So Maven provides sensible default behavior for projects. So when a Maven project is created, it creates a default project structure, and only problem with this feature is if you have unusual structure of the project, and if you can't reorganize it, then you have to let Maven go. So guideline for specification, it provides the guidelines for specification, execution, and reporting of unit tests, and those are the part of normal build cycle of Maven. So for example, uh, if you're writing test cases for your project, then where to put. So according to Maven guideline, we need to put test cases in separate folder but the parallel folder structures, and using test case naming convention is mandatory in Maven, and guidelines on how to structure your project. Once you learn this layout thing, then all the Maven project follows the same layout. So that's again the uniformity, and you can be like a really very comfortable with any project. And allowing a transparent migration to the new feature is another feature from Maven. So with this all feature, Maven makes life of Java developer especially easier. I mean a lot easier, because if you handle this all thing manually, then this is a pain. But why we need Maven in this Spring Boot tutorial series? So every time we works with a big Java projects, and those project contains dependencies, and it needs multiple builds, and there are other requirements also. So handling all those things manually is very difficult and tiresome process. So consider, in case of frameworks such as struts or hibernate or spring boot, those frameworks have its own libraries, and sometimes it needs third party libraries too. So downloading those libraries manually and putting it in our project structure at the right location is difficult task. And additionally, we need to update those libraries based on our requirements and our project version. So that is also a difficult task, and Maven can help us to manage this all dependencies and jar files. And every time we create new project, we need to create some folder structure, and which is error prone, because and especially in case of frameworks, we need to create correct folder structure, otherwise it won't execute. So it is not giving basically uniformity from project to project. So for example, if you consider, if you are working with multiple projects and every project have its own different folder structure, so it is very confusing to find particular file in the project. Every time you need to make yourself familiarize with that particular project. So in this case, Maven is providing uniformity to us from project to project. So once you understand the Maven folder structure, you are good, because you feel very comfortable with all the project structures with it, because most of the time it will be same. And building and deploying the project also is very easy with Maven, because you don't need to configure it manually, like very minute detail. You don't need to configure it, and you just fire a few commands and it will build a whole project for you. So these all were the reason why we need Maven, and how why we should learn Maven for our tutorial series. And now next, let's see how to install Maven. So first thing we're gonna need is JDK Java version 1.7 or higher for this, and set a path for that location with variable Java underscore home. So let's get into that, how we can install Maven in our PC. For Maven, we need Java underscore home path setup in our system. So to verify that, just go to your control panel, and go to system, then system, and then go to advanced system setting. So here, if you see, we have environment variables, and here if you go inside this, we have Java underscore home. I've already set up this. So if you have this, then you can it is fine. If you don't have that, then just go to new and put here name such as Java underscore home and give a path of JDK here. So it's very simple, and After this, we are ready to go for Maven. So for that, you need to open your browser and search for Maven download in the browser. So here in Google, on Google, search for Maven download, and here you have the first link from Maven. Click here, and you can see here we have four different options. So for our requirement, we need to download this binary zip archive because I'm on Windows. If you are on Linux or Mac, you can download this star.gz. Otherwise, just binary zip file is good. This is the source code of the Maven. We don't need it for now. So just go here, click here, and it will download the package in your system. So once it finished download, go to your download package and copy that. So what I'm going to do is I'm going to copy this and put it in the desktop and extract that folder here. And now if you go inside this folder, we have binary file, and this is the location that we need to set up the path. So again, as I mentioned in previous tutorials, that we have two options to set up the path. One is permanent and one is temporary. So I'm going to go with temporary again because I'm not going to use it this much. So open your command prompt, and again it's very simple. Set a path, set path equals, and you can take this location, copy that and paste it here and hit the enter. So your Maven path is set up, and to verify that, just type mvn. It is for Maven hyphen version, and this will show the version of the Maven. Yeah, so this is saying we have Apache Maven 3.6.2 installed, and it is referring this Java version that we give the path. You can go with mvn-help to get the all the commands from the Maven, and you can look into it and play around it if you want. After installing Maven successfully, we are ready to create project. So what I'm gonna do is I will create two different kind of project here. One is a regular Maven sample project, and one is web application, because I wanted to show you the difference between that two, how we can create that two, the structure, the POM file, and how Maven behaves both of them. So what I'm gonna do is I am here at the desktop right now, and I already created one folder named test here, and right now I'm inside the test folder, and there is nothing inside that test folder. Just fire a command for creating projects such as Maven, and we are doing archetype and generate. So this command is basically we are telling Maven to generate some project based on some archetype. So we need to specify this archetype later. So and then define, D is for define always. So defining group ID, I am defining group ID and give name test, and then define artifact ID and give name such as demo. And here the next one is defining archetype artifact ID. So this one is the type of the project that we want. And if you want to know more about this one, so there is online documentation on this, and I'm gonna put this link on the description so you can go and look at yourself. So there are so many different kind of archetype is there. So and I'm gonna use this one, Maven archetype quick start, and this will generate a sample Maven project. And another project that we're gonna generate is this one, the web application, and it will generate the web application project. So go to our command prompt and type Maven archetype hyphen quick start. And another argument it is taking is interactive mode. So this command is basically we are telling Maven to create project with default setting. If you put true here, Maven gonna ask you questions about configuration. So for now I put true, and it will create a project with all the default configuration with Maven. And so and I'm hitting enter. So if you can see here, it created the project, and now go inside that project. So I'm on desktop, and then test, and inside test we have demo, then source and POM. So the main thing is the structure of this one. So let me show you the structure. So for that I'm opening another command prompt, and I'm going to that location first of all. So desktop, and then test, and then demo. So here I'm firing tree, and then F. So if you can see here, this is showing the structure. POM is at the root of the folder, and then inside that we have source folder, and inside source we have main and test folder. So previously I talked that it will follow some guidelines, and this is the guidelines, that it is separating the test cases from the actual code, and it is following the parallel folder structure. So inside main we have Java, same we inside test we have Java, like that. So it is following the same folder structure. So if you want to find test class for particular class, you just need to go to the test instead of main, and location of that test class of that class will be the same. So this is actually the thing that we discussed previously about guidelines, about following naming conventions of the test cases. If you see here, it is following the standard naming convention, app test, and if you see this pom.xml file, it is always at the root. So in any Maven project, it will be here at the root of the folder. So if you once you familiarize with yourself with this Maven folder structure, doesn't matter which will be the project you're gonna work with, you will feel the very comfortable with the project. You can find easily everything inside that. This is the uniformity that we are Maven follows always. So now let's open this POM file, and inside I'm going to open this POM file with Notepad, or you can open with any IDE, and open with Notepad. So if you can see here, we have couple of things to discuss here. First of all, project tag. So project tag is a root for any XML any POM file, and POM file is as we already know, it is a project object model, and initially it was called a project.xml file. So let's go one by one with the tags. So first one is the project tag. But this tag is a root element of pom.xml file, and it is kind of HTML tag. We every time we write HTML file, we have to go with HTML, and XML is also same as a kind of HTML thing, and every time we open some tab, we need to close it. So here we open the project, and here we are closing it. So next step is the tab is the model version. So this is the version of the POM file, and it is always 4.0.0 for Maven 2 and 3. And next one is group ID. We already gave this. We already specified this at the time of creation. And then this one is artifact ID. We already specified, and packaging. So we are basically when we will see that thing in future, when we tell Maven to create to package this particular project. So Maven will come here and look that what kind of packaging we want. If we put a war here, then it will create war file. If we put jar here, then it will create jar file. And this is the version of it. So version is basically a number. If you have multiple releases in your project, then this version number is very important. Then we have name, and this is the name of the project. So we put demo for now, and this is the URL of your project if you have any website or something. And then we have dependency. So dependencies is the parental folder, and inside this we can put multiple dependencies. So for now, Maven already added JUnit dependency, because Maven already put a JUnit test case in the folder. So that's why it needed. And but we can put if we, whatever dependency we need, we just can put here. So to add any dependency in our project, we just need to come here and add some XML here, and Maven will automatically download. So it is that simple. So if we don't know what to put here, then you can go to Maven repository's official website, such as this one, and I will put the link of this one. You can go here, and let's say we are creating Spring Boot project. So we need a Spring Boot web dependency. So I type Spring Boot, and now we have test starter, auto config, and web starter. So if I go in web starter, I have this all the releases. If I want this first release, then I click here and it is giving me this dependency XML. I just copy that and paste it here, and we are good to go. So this is that. Just save it, and Maven next time will download all the libraries related with this dependency, and it will automatically put into our resource folder inside our project. So this is that simple. Maven will help with all of this. So let's create a second project, and for that I'm going to fire the same command, but here I'm going to put web application instead of quick start, and I'm going to change the name because it will create a directory inside that our folder. So I'm putting demo2, and if I'm hitting end, if I hit enter. Yeah. So now our build process is done, and it already created a web application in our directory. So let's open that. Now you can see here we have demo2, and inside that we have source. POM is always at the root. So let's check the tree structure of that project. So I'm coming out from that location, and I'm going inside demo2, and I'm firing. Now, if you look here, we have pom.xml again at the root, and inside source we have main, but we don't have test folder right in this case, because this is web application and the structure for that is little bit different. And if you see here, we have JSP file in it, and this is a little bit different than the previous one, because every time if we create web application, we cannot have only Java files. We need to have JSP, HTML, CSS. There could be some images and stuff that will go inside the resource folder. So this is how we create a web application with Maven, and I wanted to show you the pom.xml file of the web project. So let's look into that. So if you see here, we have little bit different than the previous one. So this is the previous one, and this is this actual one. So in this web application, we have demo2, that artifact ID that we gave at the time of creation, and but here if you see, we have war file instead of jar. So Java is Java archive, and this one is web archive, because this will contain not only Java files, but it will have HTML, JSP, or any web related files. So again, it will create this file automatic, and if you want to add some dependencies, just go to our Maven repository website and search for that particular library or dependency, and copy the XML and paste it here, and you are good to go. And moreover, we can create a Maven project with Eclipse, and we already created this project in our previous tutorial, but let's create it again. So go to file, and here in new we have Maven project option directly. If I select Maven, and now it is a new project, Maven wizard, and it is asking for location and stuff. So what I'm going to do is this create a simple project with archetype. So this is archetype selection thing, and if you select, then it will create the quick start project. If I don't select, then it will ask me to provide some specific archetype. So I'm going to go with a simple project, and I'm going next. And here it is again asking me group ID, artifact ID, version, name, description, and everything. We already have seen it. So let me fill it quickly. So if you see here, you can see it is downloading something. So what it is doing is Maven already add some of the dependencies inside our pom.xml, and if I open this pom.xml, I can see something is going on here. So it the download process that we just seen, it is basically going through each and every dependencies and setting up the project. So right now we don't have any dependency here, but we can add it. So the another thing that I didn't mention till now is in Maven we have one parent mom, or we can call it super mom, super pom, or mom pom basically. So if you go here, we have effective pom option, and this effective pom is that the mom pom. So what is happening basically is every time we create Maven project, Maven borrows some property from this file, and all the default setting is here. And our POM file from our project is taking some information from this POM, this super POM file, and we call it effective POM or default POM. And in Eclipse we have pretty good option. If we go in here in dependency, and if we want to add, then you can search dependency directly from here, and that is sometimes useful, so that's why I'm mentioning. And if you don't want it, then it is you can always go to our Maven repository website and copy that XML and paste it in your pom.xml file. Yeah, so this is all about creating project with Eclipse, and now let's move forward in another demo. So what is .m2 folder? Before understanding about .m2 folder, we need to learn a little bit about Maven repositories. So Maven repositories are directories or just a location of packed jar file. So Maven have most of the libraries and the jar files in the system, but with some metadata, because every time we add some dependencies, we need to identify that particular dependencies. So if you remember, when we add dependency in our pom.xml in previous demos, we add some XML over there. So that XML is a metadata to identify the particular dependencies. So that metadata contains group ID, artifact ID, version numbers, and stuff like that. So that is to identify the metadata. So every time when we tell Maven to build project, so what Maven does basically is Maven go to pom.xml file and start reading that pom.xml line by line. So when it will read dependencies, it will take that metadata, go to that particular location, and then if that library is there, then it will download in the dependencies in our local. And it is happening in sequentially. So first libraries, then second, then third, and stuff like that. So Maven have three different types of repositories. One is local, second is central, and the remote repositories. So local is a local repository in our local system for the developer's machine, and central repositories is somewhere in the internet with the Maven community. So and all the dependencies, they keep updating it, they keep putting latest version, and they keep organize that particular repository. And the next one is remote repositories. So remote repositories is basically that the repository is also on the internet, but within the company servers. So let's say in your company, if they have their own libraries or something, then they put somewhere in their local server, but for you it is on the internet, you can download, but the person which is not related with that company cannot use that, and stuff like that. So that is remote repositories. And um, so understand this flow of the of downloading dependencies. So every time when Maven execute Maven build commands, it reads a dependency from POM, and it starts looking for dependency libraries in the sequence. So first what it's going to do is it will go to your local and search for that library. If you have that library in your local, if you have that jar file in your local, then it won't go to the location. It will just take that library and put it in your project. If we couldn't found that library in your local, then it will move to the next step, and the next step is to look for that library in central repositories. So if Maven couldn't find that library in central repositories, then it will move to third one, and the third option is to look for in remote repositories. So first it will go local, then it will go to central, and then it will go to remote. And if it couldn't find a library in any of these three, then it will throw an error. Okay, so once it will download any libraries, it will put into your local repositories for the next time use. So this local repository is called the .m2 folder. And that's why, like, every time if some project is not getting any latest library, that means you already have the older version of that library in your .m2 folder. And you can delete that m2 folder, and next time you build the project, Maven will create that location, that m2 folder again. So this is the flow of how Maven downloads the libraries, and if you want to see the M2 folder in your system, then this is the location of the system, and in your C drive, then users, and then inside user you have M2 folder. But most of the time this .m2 folder is hidden. So if you want to see that, you just enable your hidden folders and you can see. Next, what is lifecycle and goals? So Maven is based around the central concept of build life cycle. What is the meaning of this is that the process for building and distributing particular project or artifact should be clearly defined. And for a developer, the meaning of this is after firing few commands, developer should be able to get the desired result of build process. And POM file will make sure the developer will get the results. So for this purpose, we have three different building life cycles to get the result, and those life cycles are default, which handles the deployment of your project, clean, which handles the cleaning of your project, and site, which handles the creation of the documentation for your project. And this life cycle is made up of different phases, or we can say goals or stages. To achieve this life cycle, we need to finish this whole goals, and you can finish one particular goal, but these goals are depends on each other. So for example, if you consider the default life cycle, which is the combination of the following life cycles. So let's say validate. So validate is the goal in default, and which makes sure project have all the correct and necessary information. And the second phase is compile. So every time you fire command, it will compile the code and create the .class files out of it. And another one is a test. Test is comes after compiled compilation of code, and it will run all the test cases to ensure our code is behaving in certain manner. And then we have package to create jar file or war file out of it. Then we have verified to get the results of integration test. Then we have install. So this install command will put this .jar file which is created in the package phase, and it will put that jar file into our local repository. And if I fire deploy, then it will put this jar file into remote repository to so other developers can use it. These lifecycle phases are executed sequentially to complete the default lifecycle. So given the lifecycle phases above, this means that when the default lifecycle is used, Maven will first validate the project, then will try to compile and then run the test cases, then it will generate the package or binaries, then it will run the integration test on that, and then verify integration test, and then install the verified package to the local repository, and then it will put it into the remote repositories. And these phases depends on each other. So let's say if I fire only test, then it have to verify first, then compile, and then test, like that. So every time I fire the command, it will run all the above phases first, and then it will go for the actual phase. So what I'm going to do here is I'm going to fire some command and show you the result of it. So first let's compile our project that we created previously, and for that we need to go to that location and desktop and test, and then we have demo. So demo is the first project that we created, the sample project. It's not a web project. So I'm going to compile this. So I'm inside demo and fire Maven and compile. So this compilation process, it will compile each and every Java class inside our project, and it will create a .class file out of it. So if you see here, our build process is completed, and now if you go in our project folder, and you can see that it created the target folder, and inside that target folder, inside classes, we have .class file of the app. So currently we have only one file inside our project. Actually two file, one is this app main file, and another one is the test class of this one. So it created the .class file for classes and for the test classes also. If you go here, you can see app test.class. So this is the compile process. Now let's try test. So if you go here and try Maven and test. So we already discussed that test is depends on compile. So first it will compile the project, and it will run the test cases on that. So if I hit this, it will compile first, and then it will run the test. So if you see here, it is running our test cases, and this is the result of our test cases. So right now we have only one test case in our code. So it is running, it ran that, and it is successfully passed, no failures, no errors skipped, and so there is no problem with our project. So it is giving build success. If you don't understand that now what is test cases, is that this anyways, I'm going to create another video on this, but just understand this thing, that every time you create any function in your project, a public function, you need to write another function to test the functionality of that particular function, and we call that test cases. And there are other frameworks for that, but just keep in mind, in the industry we need to write test cases. We have to write test cases to test our code, because if you write something like today and after 1 year you change something and that function is not behaving exactly the way you want, and then these test cases can tell you there's something wrong here in this particular function. Usually there are a couple of type of tests, and it is a topic of another tutorial, but this is the thing that we require in industry. So Maven is very helpful here. And so now moving on to next command. So after compile and test command, let's look package command. So package command, we know it will create a jar file or war file out of our project. So package command is depend on compile and test and everything. So first it will compile our all the Java files into class file, then it will run the test cases. If all the test cases are good, and then it will create a jar file or war file. So Maven and command for that is package. If you hit this, you can see first it will compile, then it is running test files, and then it will create jar file. So now in this condition, in this situation, if you go to our project and demo, and we have a target, and you can see here we have demo hyphen 1.0 hyphen snapshot, and which is a jar file. So this is the power of Maven. It is doing so many stuff internally for you, and you can run directly this jar file in some repository, and your application is up and running. And so moving forward, let's try double commands such as Maven and clean and install. So it will do two different things. It will clean the project and then install the project. So if you hit this, it will do the same procedure. It will compile the code, it will delete previous files, compile the code, download the new files, and run the test cases, and then it will install the project. So now let's take an example of document generation from Maven. So what I'm going to do is I'm going to use Java Doc plugin for this. So open this POM.xml in your notepad or in IDE, and I add this plugin with the pom.xml file. So I'm going to put a link about this plugin, from where I get it, and which represents what. So I put it here, I save that file, and now from the command prompt, if I hit maven java doc java doc, and this command will generate a documentation of our source code. So if you see here, it is downloading that particular plugin. If you see this Maven Java Doc plugin, it download and added in our project. So our build is successful, and it created this all file, and all files are HTML files. So if you go in our project, and inside the target project we have site, and here inside we have API docs, and if you open this HTML file, you can see this is the perfect documentation, the Java documentation for our project. We have only one file for now, and the description of the file is a hello world, and all the all the documentation that other developers can read, understand, and use our code. So that's all for now in this tutorial, and this was pretty long tutorial, and but we learn a lot of things about Maven and build process and stuff. So see you in next tutorial, and till then, like, subscribe, and keep learning. Thank you very much.